the IndyCar series to help make changes in safety and technology. But they're not the only racing series that NASA's working with. That's right, NASA's also helping NASCAR to help make improvements in their cars too. Of course, many of the NASA technologies found in IndyCar and in NASCAR are the same. But there are some unique characteristics found in stock car, not found in IndyCar. So what are they? I cruised down to Mooresville, North Carolina to speak with one of the premier teams in all of racing, Team Penske. Can you tell me some things that NASA has been influential with auto racing?
Yeah. In fact, we've got some good applications that we use right here. A lot of them are related to how we protect the driver, keep his head in the game, so to speak. Obviously, one of the byproducts of combustion is carbon monoxide. Bad stuff.
Now, many drivers have complained about headaches, nausea, and dizziness. So, to help these drivers with this type of sickness, Team Penske once again worked with NASA. The solution came from a NASA project called the Low Temperature Oxidation Catalyst that was originally designed for use on space-based atmospheric lasers. So Penske engineers took the basic idea from NASA and then designed a catalytic air filter that removes over 99% of all airborne particles. Once the particles are removed, the air is cooled and pumped into the driver's helmet, giving them fresh, clean air. With this new development, carbon monoxide sickness in drivers may soon be a thing of the past. And this may seem pretty obvious, but one key difference between IndyCar and NASCAR is that NASCAR vehicles have a roof. So why is this so important? Well, one big factor is heat. In an IndyCar, the driver is exposed to a 200-mile-per-hour wind stream, which keeps them relatively cool. But in a stock car, the roof keeps a lot of the heat inside, allowing temperatures to reach upwards of 160 degrees. To combat this, NASCAR teams began insulating car cockpits with the same type of thermal protection system that protects the space shuttle when it re-enters the Earth's atmosphere. This addition only added 4 pounds to the car, but cut the heat inside by over 50 degrees.
We're always questioning the design. First thing is, we have what's called a scale model program. We have a car just like this, but it's 45% of that in every detail. We'll blow that and do design studies on that to figure out, how things work.
Right.
Second thing is, we'll take these full cars and we'll blow them in a wind tunnel.
Sure.
We've done it at Langley.
NASA wind tunnel.
Yeah, there you
go.
go.
Langley.
Another way is purely theoretical, to use computational fluid dynamics to look at the flow of the car, which is all mathematical. If you take all of those approaches and combine them, you start to get a full understanding of what's going on and how to make it faster.
Doctor, what inspired you to become an engineer?
Well, NASA had a huge role in it. I grew up in that community, watched all the moon launches from my front yard. So it was just a part of that culture. And science and technology and engineering as applied science, it was a natural for me. So I couldn't say no. Haven't regretted it since.